In this program, we'll be looking at different types of mechanical couplings to see how they are used to connect the shafts of motors and other driving units and the shafts of the mechanical equipment being driven. For example, the shafts of this motor and the reducer it's driving must be connected during operation, but they must be easily disconnected if either requires repair or replacement. In addition, prior to operation, the shafts and the coupling must be carefully lined up so they run smoothly without vibration. This minimizes wear in the motor, in the reducer, and in any driven equipment, and it also increases the efficiency of the overall system. Since not all couplings are suited for all applications, we'll start by looking at some of the basic factors that affect the selection of a coupling. Then we'll see how couplings are mounted on shafts. And finally, we'll look at the different types of couplings. One of the factors affecting coupling selection is the speed at which a coupling has to work. High-speed applications usually require couplings that can be precisely aligned, especially when there is an unsupported shaft on either side of the coupling. Both the shaft and the coupling should be checked for vibration, because vibration can cause early failure of bearings, both in the motor and in the driven equipment. Accurate, correct alignment of a coupling will minimize the vibration and extend the life of the bearings. Another factor affecting coupling selection is the torque, or rotary force, which is transmitted by the coupling. Choosing the wrong coupling may result in the coupling being torn apart. Shaft size may sometimes dictate coupling size. Since not all couplings are available in all sizes, a large coupling may have to be chosen for a large shaft, even if a smaller coupling could operate at the required speed and torque. Sometimes flexible couplings have a significant amount of backlash. This means that there is lost motion or slack in the unit when the direction of rotation is reversed. Some flexible couplings are designed to reduce the backlash. Another factor that may affect coupling selection is end movement or end float in one or both of the shafts. This backward and forward movement along the length of the shaft may require a special type of coupling. Finally, coupling selection may be affected by how closely the two shafts can be aligned with each other when they are coupled together. Correct alignment is important because about half of all breakdowns of rotating equipment are due to shaft misalignment. Misalignment can cause extreme wear or premature failure of bearings and seals. Shafts may wear out, fatigue, and bend. Couplings will wear out and break. Vibration and noise will increase, and operating efficiency will be reduced. Shafts can be misaligned in 3 different ways. First, there is parallel misalignment. This is where the shafts are not lying along the same center line. One may be higher or lower than the other, or off to one side. Angular misalignment may also occur. This happens when 2 shafts intersect at an angle to each other. Most often, misalignment is a combination of these two, compound misalignment. There are 2 ways to overcome misalignment problems. The first is to use the greatest care when aligning 2 shafts. This is usually done when a motor or other driving unit is being installed, but alignment may have to be rechecked and adjusted periodically. The second way is to use a coupling that will compensate for any slight misalignment, which even careful alignment procedures may not be able to eliminate. No matter what kind of coupling is used, the coupling halves must be mounted on the shafts being joined. Most coupling halves are bored out, so the hole is slightly larger than the shaft. Typical clearance is 1 or 2/1000ths of an inch. Sometimes one side of the shaft is flattened, and a set screw holds the coupling in place on the shaft. In most cases, however, a square key is used to keep the shaft from rotating inside the coupling. When couplings are subjected to heavy shock loads, or when loads must be continually reversed, the slight movement between the coupling and the shaft can cause wear and eventual failure. To prevent this, some coupling manufacturers recommend interference fits, in which the hole in the coupling is actually smaller than the shaft it fits over. Usually, the hole in the coupling is 1/2 of 1/1000th of an inch smaller than the shaft for each inch of shaft diameter. A key is still used, but the interference fit prevents movement between coupling and shaft. To install a coupling with an interference fit, the coupling halves are heated until they expand enough to be slipped over the shafts. As they cool, the couplings shrink back to their original diameters. This is called a shrink fit. Since too high a temperature may permanently alter the metallurgical qualities of the coupling, make sure you follow the manufacturer's temperature recommendations. A good method for applying the correct amount of heat to the coupling is to use a heated oil bath. Never use a blowtorch or any other concentrated heat source, because the coupling will not be heated evenly, and the coupling may be damaged. Which kind of coupling is installed on the shafts being connected will depend on the application. There are just two basic types: rigid couplings, which provide a solid connection between two shafts, and flexible couplings, which may compensate for some misalignment. Let's look at the rigid types first. One of the simplest rigid couplings is the sleeve coupling. It is a piece of rod with a hole drilled through it and a keyway cut the full length of the inside. Holes are drilled at each end for set screws. The two shafts are connected by pushing them in at each end and tightening the set screws. It allows no movement between the two shafts. Another type of rigid coupling is the split sleeve coupling. This coupling is designed so that the two shafts don't have to be moved to connect them into the coupling. It is split down the middle so the two sides can come together around the shafts. The third common rigid coupling is the flange coupling. These couplings have two flanges, one of which is secured to the end of each shaft. Then, the two flanges are bolted together to form the coupling. This type of coupling can be used with two shafts of the same size, or with shafts of two different sizes by simply boring each flange half to fit its corresponding shaft. Either the sleeve-type coupling or the flange-type coupling can be used where shafts can be precisely aligned, or where shafts are long enough to counteract the effects of very minor misalignment. The problem with using rigid couplings is that two shafts are rarely able to be perfectly aligned. In addition, many shafts have some end float that the rigid coupling cannot compensate for. Usually, the shafts are aligned as accurately as possible. Then one of the many types of flexible couplings is used to compensate for any small degree of shaft misalignment, movement, or deflection. Many different types of flexible couplings are used, but probably the most common is the chain coupling. Chain sprockets with specially shortened and hardened teeth are attached to each shaft. Then, a piece of double chain is wrapped around them to make the coupling. Chain couplings are flexible enough to tolerate about half of 1 degree of angular misalignment. They're relatively rugged, and they're economical. Chain coupling sprockets are available with taper lock hubs and with QD or quick disconnect hubs. These special hubs clamp themselves to shafts of different sizes, so the bore of the sprocket does not have to fit the shaft precisely. Another type of chain coupling uses standard stock sprockets, like those for power transmission chain drives. These sprockets may be taper lock, QD, or they may have a standard stock bore. The chain for this coupling is special Delrin chain, which has several advantages. It requires no lubrication. It allows for 1 full degree of misalignment, and the pins can be removed to disconnect or reconnect the chain. Although chain couplings are frequently installed without a cover, the use of a cover and grease lubrication will extend the life of the coupling, in some cases by as much as 2 or 3 times. Covers may be plastic or they may be metal. Another common type of flexible coupling is the gear coupling. Each side of this coupling consists of 2 parts. One part is a gear that is mounted on the shaft. The other part, a cover, has internal teeth that mesh with the teeth of the gears on the shaft. The 2 halves are bolted together to assure correct alignment. The gear coupling can also be assembled with shear pins between the halves. Applying too much rotary force or torque to the coupling shears off the pins. The coupling halves, along with the shafts they are attached to, run free. A gear coupling with shear pins is used as a torque limiting device. Many gear couplings allow 1 full degree of misalignment. To allow for greater misalignment, some manufacturers curve the teeth. Depending upon the curvature, as much as 3 degrees of angular misalignment are possible. Some manufacturers also provide gear couplings with wider teeth. The wider the teeth, the more end float the coupling can accommodate. Another type of flexible coupling has a flexible center. For example, one very basic type uses a small piece of rubber hose which is clamped onto each shaft. Another kind of flexible coupling has a flexible rubber center disc which is inserted between the two coupling halves. A similar coupling has a continuous flexible center ring with notches that are plugged into each end of the coupling. Together, they make a flexible unit that can allow for as much as 2 or 3 degrees of misalignment. All the movement takes place in the rubber. Another style of flexible coupling is referred to as a rubber tire coupling. Shafts are connected to both sides of the flexible tire, and all the flexing occurs in the tire itself. Another kind of coupling is the steel grid coupling. Its two halves are connected with a continuous grid of flexible steel which locks around the center of the coupling but still permits it to move. The coupling includes a cover. In this lesson, we have seen that couplings must be correctly aligned to ensure minimal wear and trouble-free operation. We've seen how different couplings can be attached to the shafts they connect. And we've seen some of the many kinds of couplings that are used in different applications.